We are going to learn the Cisco Secure SD-WAN. So Cisco does not only call it SD-WAN, instead they call it Secure SD-WAN. And there is a reason behind they call it Secure SD-WAN. In fact, all of the vendors nowadays calling their SD-WAN solution as a Secure SD-WAN solution. But yeah, in Cisco, it has been there since long time, the Secure SD-WAN solution. So this is what we are going to learn. And the agenda of this training would be to cover all these topics, right? So let me just display the agenda here. So we will be covering, like, basically we have divided this entire training into multiple modules. So in module 1 we are going to talk about the architecture of the Cisco SD-WAN. So when I say about the architecture, which means that we are going to learn about the different components which are included within the Cisco SD-WAN. So basically we get like vBond, then vManage, and then vSmart, right? Now one more thing, there's a disclaimer that I would like to provide. Cisco has recently renamed or rebadged all these terminologies. Now they're not calling it Cisco SD-WAN or Secure SD-WAN. They are calling it Catalyst SD-WAN. So they have renamed these terminologies. Like when I say SD-WAN or Cisco SD-WAN, they are calling it Catalyst SD-WAN. And also they have renamed this orchestration plane or vBond. They have renamed this vBond. They have renamed vSmart. They have renamed the vManage. Now I will let you know that which all things they have renamed. They have just renamed. There are no changes. The functionality is still same as before. So we are not, we have not updated the PPT so far. So that's why this PPT is still containing the old names here. So do not get confused. If somebody has gone through the Cisco's website in recent times, so probably they must have found some new names there, but don't get confused. It's all same thing. I'm going to provide you all the explanation around those new naming conventions as well, right? So don't worry about that. So that's the disclaimer that I would like to give you in the beginning of the training. So the architecture. So first we are going to cover this architecture of Cisco SD-WAN. And during this discussion around the architecture of the Cisco SD-WAN, you will get to know that what is the use case of the vBond, how does it work, right? And same goes with vManage, which is also known as management plane, and then vSmart, which is also known as control plane. Now when it comes to the control plane, then obviously you cannot leave a protocol called OMP behind. This protocol is very, very important. So it's like quite similar to like what we have in when we talk about the BGP, right? Border Gateway Protocol. So you can simply compare this OMP with the BGP, and you would see that it has kind of similar functionalities as BGP do. You will understand that with time. And then we're going to talk about the data plane devices, which means that we are going to talk about the managed routers. So when I say managed routers, so the managed routers are still routers. However, there are some new terminologies such as TLOC, IPsec, vRoutes, or BFD sessions. So earlier IPsec tunnels were optional in SD-WAN. It's like kind of mandatory thing. We never heard about the TLOC earlier, or in past. In traditional routing we never heard about the TLOC. In fact, there was no TLOC. But in SD-WAN, yes, you would learn about this TLOC, that what it does, what is the use of TLOC onto data plane devices, then how IPsec tunnels are built. So in short, I would say that TLOC will help manage routers to establish the IPsec tunnel. So IPsec tunnels would have dependency over the TLOC. TLOC is nothing but it is just a transport locator. Now it carries a lot of attributes that we will be discussing going forward. So we have got then vRoutes, which means the routing table. Then we have got the BFD. So earlier BFD was an optional thing, but now it runs automatically inside the IPsec tunnel to measure the performance of the IPsec tunnel and also to check the liveliness of the tunnel. So that's what BFD does. So it gets enabled automatically. You don't do anything by your own, or you don't do anything manually. Then obviously you're going to talk about, like, we are going to talk about the different platforms, right? Like we have got different types of platforms. So I will explain that, okay, these all are the managed routers that we can use in the production environment. And I'll give you some use cases that, okay, if your customer is like a big customer, then you will be talking about the throughput, right, and the services that they want to use, and based upon that you will be opting your platform, right, or VANages or VH routers or CH routers, right? Now again, they are calling them now Catalyst VANage routers, right? So again, they have renamed them. And then obviously they have a topic called Cloud on Ramp, right? Or Cloud Express. Earlier it was known as Cloud Express. Cisco renamed it as Cloud on Ramp, right? So you have got SD-WAN Cloud on Ramp for SaaS, software as service, and then IaaS, right? Infrastructure as service. Right, so they have just description, not the labs. But what we will be doing is that for software as service, I will be doing the labs so that you can understand it fully. And for infrastructure as service, I'll be doing just demonstrations right in front of you. It will not be fully lab, but yes, it will be a kind of demonstration that how you can implement infrastructure as service using Cloud on Ramp, right? Or Cloud Express. So that's what we're going to talk about during this section 1, right? Then we have got section 2, where you will be learning about the controller deployment, and we are going to perform the on-prem deployment, right? So we have got like two different options when it comes to the controller deployment, right? So we can deploy the controllers either in cloud or maybe on-prem, right? So like ideally you get these two different options available in Cisco SD-WAN. And since you can deploy the Cisco SD-WAN controllers on-prem, that also gives Cisco a little edge over other vendors. There are some other vendors as well for which you could deploy the controllers on-prem, right? But most of the SD-WAN vendors do not provide this that much flexibility, like deploying controllers on-prem, right? So that is available in Cisco. In fact, when it comes to the lab or practicals for the controller deployment, we are going to perform on-prem deployment only, not the deployment inside cloud. Like obviously, as of today, you can deploy your control components in AWS environment. You can also deploy them in Azure environment, right? So like in public clouds also you could deploy them, but also you have this feature to deploy them on-prem as well. So basically we are going to perform the on-prem deployment. So the labs will be done based on-prem deployment. So we will be having like kind of ESXi server. So I'll be explaining you that how you can deploy the control components over the ESXi hypervisor, right? So hypervisor could be different types of like we have different types of hypervisors available out there in the market, right? Such as ESXi is there, then open source KVM is there. Then I believe there is one hypervisor provided by Microsoft as well, right? So we have got like multiple hypervisors, but the SD-WAN control components can be deployed. Like I can recall it from last time. So they used to provide us only two different types of images, the QCOW, which is used for KVM, and the OVA, which is used by the VMware. So these are the two hypervisors. On top of that, you could deploy your control components. And this is something that we will be performing, right? So we will learn end-to-end controller deployment, like how to bring up the control plane. Even it will include the controller deployments, right? So you would learn that how to install vManage, how to install vBond, then how to install, the vSmart, and then how to make management connectivity in between them, how to make then transport side connectivity or data side connectivity, right? And then how to bring them, or how to install the certificates, because what they do is that they use the certificates. You can see the right configure certificates in the device list. So all these devices are going to use digital certificate to authenticate each other. So we will be learning that what are the certificates, what are the digital certificates, what are the CAs, how many different types of CAs we have, and how can we generate the certificate signing request from the control components, and then how can we install the certificates onto control components against those CSRs, right? So first we will get a signed copy of the certificate from a from a CA server, right? And then we can get them installed onto these control components, because at the end of the day, all these control components will be authenticating each other using those digital certificates only, right? So going forward, you're going to learn all those kind of things, right? So not only you will learn about the controller deployment, but also we are going to have a discussion around the certificates, like what are the digital certificates, what is the CSR, and then what are the root cert chains, right? And then what are the or what is the identity certificate? So that type of discussion also, we will have during these sessions. Then troubleshooting in case if control connectivity is not coming up, let's say control plane is not coming up. So then what all uh, possible things could be, right? So you can go back and check them and then you can fix the problems, right? So we will have one session around the troubleshooting control plane connectivity as well, right? So that's what we will be discussing. So that's all about the section 2. And then we have got section 3 where you will be learning about the router deployment, right? Which means the managed router deployment, right? So first thing is first that you would learn that how to onboard a managed router. So like nowadays, a feature called PNP or ZTP, zero touch provisioning or plug and play. Those services are pretty much, I mean, those are popular, right? As of today, like most of the users are using PNP, ZTP. Not most, but yeah, I mean, I would say like kind of 50%. So 50% customers, they prefer to use PNP or ZTP, but rest they ideally onboard their managed routers manually, right? So that depends basically the type of customer that we are working with. And then orchestration with zero touch provisioning and PNP, that's what I said. And the data center and regional hub deployment, how can we deploy the routers in data center? How can we deploy the routers in regional offices as well, right? So that's what you're gonna discuss under 3.1. Then 3.2 says data plane, right? So how data plane connectivity will come up between the remote sites, right? So obviously over there, then TLOC will play a very important role, right? Then TLOC extension is there, then dynamic tunnels are there, then underlay overlay connectivity is there. So you must be pretty much clear with those two terminologies like underlay and overlay. And this is not something really new in SD-WAN. It has been there since, we had like kind of DMVPN or GRE tunnel or IPsec tunnel. So these terminologies like underlay and overlay, right? So these two terminologies has been there in traditional networking. So we should not get confused with underlay overlay, although I'll be explaining it to you that what are the differences in between underlay and overlay so that you are pretty much clear with those two terminologies, right? Okay. Then obviously we have got OMP, Overlay Management Protocol. So it's kind of new protocol that you will be learning. And this protocol is supported in Cisco SD-WAN only. And it is a Cisco proprietary protocol. Okay. OMP is not kind of open source. In fact, in SD-WAN, like when it comes to the software defined wide area networking, still there is no open source kind of technology, which is popular, right? Like all vendors are using their own technology. Like in Cisco SD-WAN, you would see that OMP is there, right? And then if you talk about the Velo Cloud, or maybe if you talk about the CloudGenix, so all of these vendors are using their own mechanism, right? And they have the proprietary technology, right? So, I mean, they have registered their technology as a proprietary. So like in SD-WAN, you would not find any kind of like terminology like open source, right? And then we have got like TLOCs again, and then configure, verify, CLI. We manage feature configuration templates. So you're gonna learn about the templates, and templates are very important, right? So templates are nothing, but it is a way of doing the configuration onto your devices. So I'm not sure that how many of you have already worked on the templates, but nowadays, like these templates are pretty much famous everywhere, right? Whether you are working on, let's say, if somebody is working on Panorama, right? Like Palo Alto firewalls, and then they have got the management server called Panorama. So on Panorama, again, you create the templates to make the configuration onto your Palo Alto firewall. And similarly, if you talk about the FortiManager, again, you create the templates there, right? And then, I mean, most of the vendors are nowadays using templates for making configuration onto the end devices, END, right? End devices. So here in Cisco SD-WAN, again, we have got the templates, right? So we will be creating templates, and then we will be attaching devices to their respective templates. So whatever configuration you would have on that template will get pushed onto the managed router, right? And using those templates, you would learn that how to get VRRP implemented. So yes, VRRP is still supported in Cisco SD-WAN. The OSPF is still supported. The BGP is still supported, and EIGRP is still supported. And you're gonna learn that how can we get these protocols implemented using templates, right? So you would learn that we would be covering all these topics. Now, after templates, the most critical topic would be the policies. So if you learn the templates and policies very well, trust me that your SD-WAN is good, right? Now you can do whatever you want. Although troubleshooting part would be a little different, but most important thing would be to understand the templates, like the way to use which type of template and how to create templates, right? How should we build the templates? That's one thing. Second, how should we build the policies? If you understand only these two topics, right, templates and then policies, which means that it has covered somewhere 70 to 80% of the SD-WAN, right? So policies, again, very important topic, right? So we have got like control plane policies. So ideally, if you compare the control plane policies with the traditional type of networking, right? So traditionally, we used to have route filtering, right? And you must have done the route filtering in BGP. You must have done the route filtering in OSPF. So you do the route filtering using route maps, right? You do the route filtering using route map. So here we are calling it like kind of control plane policies, right? So using control plane policies, you can perform route filtering. In fact, not only route filtering, but also you can manipulate the path selection. Like even in traditional routing, like especially in BGP, we used route maps to modify the BGP path attributes and to modify the best path selection, right? Similarly, we can use the control plane policies here in Cisco SD-WAN, right? And then we have got the data plane policies, right? So even data plane policy was already there in traditional routing, but here in SD-WAN, they have taken this data plane policy at next level, right? So earlier we used to call it PBR, policy-based routing, and that was a data plane policy, right? If you do remember that. So we had PBR, which is also known as policy-based routing, right? So if somebody remember the functionality of the PBR, it was totally for the data plane, not for the control plane. So they have made a lot of enhancement into that, right? And then they have came up with the data plane policies in Cisco SD-WAN. Then it also supports the end-to-end segmentation. So we're going to learn that what is end-to-end segmentation and how does this work, right? So obviously we have got like VPN segmentation, we have got topologies, right? So how you can build like kind of full mesh topology, how you can build the hub and spoke topology, right? And then VPN segmentation is also there. So basically it's not kind of IPsec VPN, it is kind of VRF, right? So in SD-WAN, when I say VPN, you can think of, if I'm saying just VPN, not IPsec VPN, right? If I'm saying IPsec VPN, which means it is an IPsec VPN. But when I say just VPN, right, VPN segmentation, which means we are talking about the VRFs. And VRF is not something new in SD-WAN, right? It has been there from long time, very long time in Cisco networking, right? Then we have got application aware routing, where you define that, hey, for YouTube, I want to use the internet connection 1, but for Facebook or for other applications, I want to use internet connection number 2, right? So that's an example of the application aware routing, right? So that is something, which is really important. And this is something which has made this technology more popular because of its capability of application awareness, right? Since these routers are going to be application aware, so you can define your policies based on the applications that for example, as I gave you one example, right? So for YouTube, you can use one circuit. For other applications, you can use the other circuit, right? So this is what you can use by the help of application aware routing. So nowadays, all the routers are application aware. So you can define the policies based on your applications. Now, I hope everybody is just getting an idea that what I'm talking about here, but obviously we're going to learn each one of these topics in very much detail, pretty much details, right? So don't worry about that. For now, I'm just giving you an idea that which all topics you are going to cover. Then DIA, direct internet access, is one of the very important feature or I would say, pretty much famous feature that we use in Cisco SD-WAN, right? So ideally, what it does that using DIA, direct internet access, right? So, for example, if we have got some SaaS-based applications such as Office 365, including Microsoft Teams or maybe Salesforce, right? So you have so many software as services based applications, right, out there in the market. So ideally, what happens is like traditionally, what was happening that from branches, you were backhauled into data centers or maybe into kind of regional hub site, right? And then from over there, you were going to the internet and then you were having access to those applications. But in Cisco SD-WAN, they have launched or they have this feature called DIA, direct internet access. So all your internal corporate traffic will still go to your data center. But if you have got the local internet connection at branch, then you can configure your router that, hey, for YouTube or maybe let's say for Office 365, data should go directly over the internet. So that's DIA, direct internet access. So you can define, again, DIA is part of the data plane policy itself, right? Then we have got the security and then quality of service. So when it comes to the security in Cisco SD-WAN, it supports lots of, kind of, you can compare it with NGFW or next generation firewall, right? So it has so many different security features, such as it has got application aware enterprise firewall feature. Then it has got IPS, it has got URL filtering, it has got AMP, and it has got SSL and TLS proxy. And I'm not talking about leveraging the cloud-based solution. No, I'm talking about the on-box security features, which means you're using a managed router, and at the same time on that managed router, you can enable these security features. So these are also known as on-box security features, right? So these all are the on-box security features, but also you can perform the cloud integration. So for example, if you have got Zscaler or Cisco Umbrella kind of thing, so you can integrate all your managed routers with those cloud providers, right? And then you can apply the policies inside the cloud, right? Especially for SIG, secure internet gateway, you can use either Cisco Umbrella or you can use Zscaler. For DNS security, it is mandatory for you to use the Cisco Umbrella. Without leveraging Cisco Umbrella, it is not possible for you to deploy the DNS security. But apart from that, if you just wanted to deploy, let's say, application aware firewall, fine. You have that on-box feature. Then IPS can also be implemented on the box itself, like on the router itself. Then same goes with URL filtering, AMP, SSL, and TLS proxy. Even you can perform, when I say SSL and TLS proxy, which means you can perform SSL decryption on these routers itself. You do not need any additional firewall, but you must be cautious. You must be careful while enabling all these features, right? And not all platform supports these security features. That is another thing that you must keep in your mind. Not all platform supports all these security features, because if you're looking to enable these security features onto your platform, onto your managed router, then that managed router must have some additional CPU cores, but not only additional CPU cores, but also some additional memory. If your router doesn't have any additional CPU cores or maybe memory, then it would not be possible for you to get these security features enabled, except application aware enterprise firewall. For this firewall feature, there is no need of having any additional resources, hardware resources on your managed router. But apart from that, for all other remaining security features, it is mandatory for you to have additional CPU cores and memory on your managed router. All right, then it has also got the quality of service. Now remember, it has got so many features within quality of service, such as scheduling, queuing, shaping, policing, marking, and of course the per tunnel and adaptive quality of service. So all these features are supported there. Especially you're going to use policing and shaping. These two are the most important things that we use in production environment. Like for example, nowadays the WAN circuits are terminated using the fiber optic, right? And those are like 1 gig interfaces. But let's assume that you purchased only 200 Mbps of the bandwidth, but your WAN edge router would try to send data towards the service provider at the higher rate. Like kind of it can reuse that 1 Gbps speed, right, for sending your data. Now if you are trying to breach your traffic contract, then service provider might drop that data. So in that condition, you may have to apply the shaper at the customer end, right? So customer will have to shape the data so that customer do not breach the contract, and service provider, hence service provider will not be dropping the customer's data. So wherever you have got like kind of contract, and that's what we always have, right? I mean, obviously you would always have the traffic contract between customer and service provider. So customer must not breach that contract. To achieve that, you will be using shaping. Then policing is also there. Like for example, if you have allowed your lane users, it's just an example that I'm giving you for the use case of the policing. So let's assume that you have got your lane users who are allowed to have access to the YouTube, right? But then you do not want your lane users to access YouTube at higher rate than 5 Mbps or maybe 2 Mbps or 10 Mbps, whatever, right? So for that purpose, you can again apply the policer for that YouTube application, that if somebody is trying to send data at higher rate than, or receive data at higher rate than 10 Mbps, then policer can police that data or can drop the data. And marking, obviously you can perform the marking if needed, right? So queuing is also there. But do not think of that the SD-WAN quality of service has got to the same level as we had traditionally. No, it is still has not gone up to that mark or up to that level where we used to have quality of service in traditional networking. If you remember, traditionally we had concept of CBWF queue, which was class-based weighted fair queue, and of course LLQ, where we could create up to 64 queues, right? And inside each queue we could configure different things, right? Like we could enable shaper, we could enable policer, we could define the bandwidth, right? We could define kind of marking for each queue. But all those features are still not supported in Cisco SD-WAN. Yes, basic quality of service is there. Like you can create queues, but not up to 64. It supports only 8 queues. Then inside a single queue, it's not possible for you to do everything like what we could perform traditionally. But yes, Cisco is still working on it, and I'm hoping that going further, Cisco will include all those features as well. Okay, then finally, it's management and operations. We will be talking about the authentication, monitoring, and reporting from the vManage. So obviously, it has got like role-based access control. So we will have all that kind of discussion over to vManage, right? How we can configure role-based access control, how can we add users, how can we integrate vManage with AAA server, like kind of TechX server for authentication purposes. And then obviously I am going to describe around the REST API monitoring as well, like how you can utilize those REST APIs, or in fact, I would say which all REST APIs are supported by the vManage. That's what I'm going to discuss with you. Not only that, but also I'll be explaining that how you can upgrade the images of your different SD-WAN components by sitting onto vManage only. So that's a good thing about the Cisco SD-WAN, that if you are logged on to vManage, you can perform everything from that vManage. You don't need anything extra. So if you want to perform, let's say, OS upgradation, that can be done from the vManage. You are doing some troubleshooting, you can do it from vManage. You want to make the configuration onto other components, you can do it from vManage. So whatever you are doing, you can do it from vManage. It's kind of centralized device, right? So that's that. So these all are the 6 sections which we are going to cover during these training sessions. right? The number of labs that we are going to cover, you can see now, right? So I'm going to explain that which all labs we are going to perform during this training. So obviously, SD-WAN components, the CS server, right? And installing certificates and everything. The vManage initial configuration, GUI mod, vBond CLI configuration, install certificate, onboard your vSmart install certificate, and then perform initial configuration to manage router using CLI, registering device, registering manage routers in vManage, perform initial configuration using CLI, right? And then C edges. So we have got like V edges. V edges are from viptela, right? I will come to that topic as well. I will be discussing the differences between viptela and Cisco, right? I will explain that what was the viptela, how it became Cisco. Okay. Then feature device templates. So obviously you're going to learn about the templates, different for different features, right? So you would be enabling templates for AAA, BFD, OMP. Then we have got static routing, OSPF, BGP, ICRP, VRRP, TLOC extension. So a lot of things are there. Then we have got the policies. So you're going to learn how to build hub and spoke policy, how to implement traffic engineering, right? Then how to perform service insertion, and of course the service chaining, right? The route filtering is there, TLOC filtering is there, route leaking is there, VPN membership is there. Then we have got data plane policies, like how to set a preferred transport. Let's say I said for YouTube, use this transport or that transport. Then application aware policies, then NATing is there, DIA direct internet access is there, CFlowD is there. So traditionally we used to call it NetFlow. Here in SD-WAN we call it CFlowD, so it's the same thing. Then QoS concepts are there, right, in Cisco SD-WAN. So you would be learning, you would be implementing quality of service policies, right? And packet loss mitigation, like how can we mitigate the packet loss in Cisco SD-WAN using different mechanisms, right? So packet loss mitigation is there. Then security policies, application aware firewall, IDS, IPS, URL filtering, AMP, DNS or web layer security is there. Then there is a lab for cloud on ramp for SaaS, and there is a demonstration, right, for cloud on ramp for infrastructure as service. So I'll be giving you demonstration for that, right? Then obviously I'll be explaining that how we can perform monitoring using vManage, how we can validate the syslog and TCP dump, how can we use TCP dump onto VEdge routers, right? And then how we can leverage the API docs to make REST API call, right? And then finally, we will be performing a lab to perform the software upgrade onto vManage, right? So on vManage, we will be performing the software upgrade for each one of the component, right? So that's about the verifying day 2 operations. That's it. This is our lab as of today, right? We will be updating it a little. It has not been updated so far, but yes, we are going to update this sooner, right? But the IP addressing schema is going to be same. So you don't need to worry about it. It will be modified soon, but as of today, this is the lab. So in this lab, you can see in left side, in your left side, right? This is the left side. It's kind of DC. This left side, this entire block is for DC. In DC, you have got like your control components installed. So you have got vManage, vSmart, and then vBond. You have also got the CH router installed inside the DC. There are two transports, internet service provider and MPLS provider. In DC, you have got internet connection, you have got MPLS, both. And you have got site 1. At site 1, you have got VH1, VH2. So these are the VH routers, not CHs. Then we have got site 2, where we have got just one, like it's a single CPE site, right? So it's a single CPE site, and site 1 is a dual CPE site. And then site 3 is also there, which is again dual CPE, but without redundant WAN edge connections. That's where you will be implementing TLOC extension. So this site 3 is mainly meant for implementing TLOC extension. Okay. So this is the lab that we are going to leverage, or we are going to utilized during our training. Any questions so far?
No.
All right. Now let's get back into the history of the SD-WAN. So first, what happened
So,
was,
so you're telling G scalar, you're telling G scalar and Z scalar is a both are same or different?
G scalar
And Z scalar. In my organization, you're using for
Z
Z
scalar.
scalar.
I mean, you call it Z scalar or Z scalar is the same thing.
Yeah. Sometimes Z scalar is down. Is instant is came, so that's why in doubt only. Yeah.
Okay.
That topic also is covered, sir.
No, sir. No.
Yeah.
No,
Okay. Thank
that's
you.
not. Because that's totally different, right? Z scalar. That's kind of an integration. So SD-WAN can be integrated not only with Z scalar but also with Cisco umbrella and also with the kind of Palo Alto Prisma and other kind of stuff, right? So
Yeah. Okay. Got it. Thank you.
all right. So let's talk about the software-defined networking first, right? Software-defined networking, how it came, what happened, right? So basically, SDN is not something which was really needed. Nobody wanted this SDN, software-defined networking. But like if you talk about the traditional networking. Now, I will talk about the networking only because this automation or this SDN does not only cover networking, but also it covers that one system administration or server administration. That is also covered by the SDN, software defined networking. But let's not talk about that. Let's not go into there. Let's talk about the networking only. Do you remember that earlier we used to have this kind of connectivity for most of the organizations, right? We used to have like one DC. Let's say there is DC1. We used to have a DRDC as well, which was DC2. Those DCs were interconnected. And then both DCs had connection from MPLS provider 1 and MPLS provider 2. Let's say it was 1. Like this. And also they had connectivity from an ISP. They had a large pipe in both DCs from ISP, right? Then we had branch offices like branch 1. Ideally, we would have MPLS connectivity from both providers. Then branch 2. Branch 3 and so on. You would see if people, even in today's world, even in today's world, you would see that most of the customers are having this kind of connectivity, right? Do you all agree with that or not? With this type of connectivity based on your experiences?
Yes.
Okay. So for example, if there was an application hosted in any one of these data center, let's say in DC, primary DC, because it was your primary DC, right? So if DC1 was your primary DC, then everyone from branch office will come to DC, primary DC, will access all the applications hosted in this primary DC, right? Will access all the applications hosted in this primary DC. And not only those applications hosted inside this primary DC, but also if they wanted to have access to the internet, the branch user will first backhaul into DC, and then from DC they will go to internet, and then from internet they will come back to DC, and then will go back to the branch. We used to have this kind of connectivity, and we were happy. Everyone was happy. We were managing this network. Like obviously, we used to manage all this type of connectivity. We were using BGP there sometimes. Sometimes we were using Between PE and C, we were using OSPF. Sometimes we were using EIGRP. So we all were happy, right? I mean, customer was happy, we were happy, but at the same time, we had so many issues. How? Let me explain. In internet world, internet world kept on growing, and then a new terminology came up. I mean, it came up, right? A new terminology came up into the market, that was SaaS, software as service, right? So applications were introduced by many companies as a SaaS service, right? Software as service, right? Like Office 365 is one of them. Box is one of them. Dropbox is one of them. Salesforce is one of them, right? There are many, right? Now, and those applications became more, these applications became rich, right? More heavier than before or than ever. Like earlier, we used to have smaller applications. Like if you compare Windows 11 with Windows XP, I believe that every one of you must have worked on Windows XP. I'm not sure, but I'm hoping, right? That you must have heard about the Windows XP as a client OS, right? If you compare Windows XP with Windows 11 that we are using in today's world, so you would get to know that what is the difference. Like Windows XP could run on a device where you had like 512 MB of RAM, 512 MB of RAM, right? Or maybe 1 GB of RAM. And then if you were having like a normal CPU of having maybe 2 cores or 2 cores, right? In fact, a single core, right? That was sufficient for Windows XP to run. But now Windows 11 is much heavier. That requires at least 8 GB of RAM. That's the minimum requirement, right? And then it has got a minimum requirement of 4 CPU cores, right? And that's what you get with those laptops or machines where Windows 11 is installed. In similar way, applications have become now rich, much more heavier than before, right? So if you are still using, right, the same infrastructure to access those applications, those SaaS-based applications, right, the end user machine would still use this MPLS, right? MPLS connectivity will backhaul into DC and then would go to internet provider. So first, that this DC is bottleneck here, right? Everyone is coming to DC and then you are going to internet. So it's kind of bottleneck for your internet connectivity, right? Because everyone is backhauled into DCs. That's one thing. Second, now you would require to increase this MPLS bandwidth as well. And MPLS is much expensive. Don't you all agree with that? That MPLS is expensive than internet, right? Since MPLS is much expensive than internet, right? So obviously the cost, the recurring cost has increased, right? And even since more and more applications are moving onto the internet, right? Right? So and like YouTube, right? Let's take an example of YouTube. So if somebody is playing the video, right? Because all the users have got internet access via data center. So even if somebody is playing YouTube video, first they will come to DC, and then from DC, they will go to internet. And that way traffic will come back for the YouTube itself. And YouTube is also, like let's say they are running or they are playing the video in HD quality, right? So just imagine that how much of bandwidth one user can consume. So that's where we started having problems with this type of architecture. This is exactly we had the issues. There was a bottleneck for the internet, right? Then more and more applications are moving towards the internet, but the internet was still reachable through the DC, right? So the overall performance started degrading, right? Applications kept updating, but network was still same. The infra was still same, right? The next problem that we had here, obviously the MPLS cost has got increased. And here, let's say you had a bigger pipe of internet circuit, right, in DC, but still it is a bottleneck, right? It is adding more latency as well, right? We had other problems as well, right? So for example, this MPLS, I'm just giving you an example, right? So this MPLS 1 is Airtel. Airtel is one of the provider in India. The MPLS 2 is from Tata. Tata is another provider within India, MPLS provider, right? Now, for all these remote branches, let's say earlier, Airtel was the primary WAN connection, right? We were using Airtel as a primary MPLS, right? Now, management has decided to change it over to Tata, right? Like management has asked that, hey, change your primary connection as Tata, make Airtel as a secondary. Now, can you tell me that where, like at which all sites, what type of changes you would be making? If you do remember that, if you have done that in past. So if you have done that in past, you must have observed that ideally we use BGP in between P and C. You are going to modify the BGP attributes for each one of the branch. Let's say you have got maybe 1000 branch offices, right? You need to go to each and every branch manually, and then you need to modify the BGP attribute so that you can define your Airtel, your Tata as a primary provider, and then Airtel as a secondary provider. So you would require to log into all those 1000 branch routers, the VAN edge routers, and then you will have to modify those BGP attributes. Just imagine that how much time it will be taking, right? That's one thing. Second, obviously, there are chances that you might make mistake at one of the or couple of the sites, and then those might go down as well due to the changes that you have made, right? Okay, this is one problem. Like it was so tricky, or it was so difficult, right? These type of changes were so difficult to manage, right? I'll give you one more small example. Let's assume that SNMP string, right? You had SNMP string configured, the community string, and then you got to know that it was compromised, right? Let's say SNMP community was compromised. So at same day, then higher management did ask to get it updated everywhere, right? Since you're not using any kind of automation, there is no controller based networking, nothing. So you decided to change the community string manually on all devices. And I've done that. This is my personal experience that I'm explaining you. So let's say we had 1000 devices, right? We had to log into all 1000 devices. We had to update the SNMP string manually over there. Just imagine that how painful it could be. Like you have got a team of 8 people, right? And they are working, in shifts. So like still, if we are asking everyone to just work on the updating SNMP string and to log in onto different devices, still for getting this updated on 1000 devices can take like 24 hours or even more than that. If everyone is working in all shifts, if everyone is working on all those devices, because you are doing it manually, right? Not only that, just imagine that you have changed your DNS server IP address, right? You have changed your NTP server IP address. Just imagine that how painful it was. Although these changes doesn't happen so quickly, but still there are probability, right? That you updated your DNS server IP address or NTP server IP has got changed or whatever, right? Even if you are making changes, like for example, if you are updating AAA server, right? Like you had a Radius server or maybe kind of TechX server. Now the AAA server IP address has got updated. So not only that, sometimes you have to modify your primary secondary best path, but also you can modify, you might get your SNMP string modified, your AAA server modified, DNS server IP address modification, and TP server IP modification. And sometimes you may have to modify, some other stuff as well, right? But just imagine that if you are doing it manually, how much time it would be taking, and how difficult it could be for any team. We did it, right? I have done this manually, like updating the SNMP string due to, since it was compromised, right? So the community got compromised, and then we had to update this SNMP string everywhere on all of the devices, right? So I have gone through that pain. So there was a pain with traditional networking, right? Not only that, I've seen, like, I was sitting with one of my fellow, right? And he was making some changes, right? So he was making the changes on the ACL, which was applied on the WAN facing interface. And they had just one WAN interface. Let's assume that for now. Or maybe they had like two WAN facing interface, but they had a common ACL that got applied, or that was applied on both of the interfaces. So he made the changes to that ACL and made wrong changes, right? And then he lost access to the device. The device was locked. Why? Because ACL was blocking the access. Now, because ideally, the jump host servers would be installed inside the data centers, right? And being an engineer, we go to that jump host and then we make the configuration onto devices from that jump host only. So from that jump host, we lost access to that branch router. And now you need to recover that router, right? How would you be doing that? How painful it could be? Maybe this location, this branch was in a remote area. So it might take field engineer to reach there maybe 24 hours, 48 hours, maybe more than that, 72 hours, even more than that, right? So it was so difficult, actually. I mean, I have given you so many examples here of the difficulties that we had with the traditional networking. I'm not saying that we are not using traditional networking as of today. We are still using it. Some customers are still using it, but they are facing all these issues, right? Then, again, management reached out to the developers that, hey, give us some solution, because we are doing it manually and it's not a good idea, right? That's where this SDN came into the picture, software defined networking, that let's not do these things manually. Let software handle these kind of changes or these kind of things, right? Even troubleshooting takes a lot of time, right? If we are doing the troubleshooting in the network manually, it takes a lot of time to perform that troubleshooting. Everyone would agree to that, right? Each one of you would agree with that troubleshooting takes a lot of time. The only solution was SDN. Then the higher management, they reached out to software development team, right? And they said, okay, these are the problems that we are facing, and then they started working on it, right? So SDN, software defined networking, is nothing but it is a controller based networking, right? In nutshell, it's a controller based networking, right? Where you install a controller, a centralized controller, and then you control the entire network from there. Like if you're making the changes, then you define it on your controller, and then controller will be responsible to push it onto many devices. Like, for example, I'm just giving you an example. Let's say you created a Python script, right? So even I'll give you one more example of taking backup of the device configuration, right? So earlier, I do remember that we used to take the backup manually, right? So for example, I was doing the changes on 20 firewalls, or let's say 50 firewalls. So before making the changes, I used to take the backup of all those 50 firewalls. So we were doing it manually. So like hours were spent just to take the backup of those 50 firewalls, right? And then we had then we created a bash script. So earlier it was not Python, right? So in most cases we were using this bash script, and then Perl came into the picture, right? So we were using Perl script to take the backup of the devices, and then finally Python came into the picture. Then we created a Python script to take the backup of the devices. So what Python does, it's kind of like, it's a controller again, right? It's a controller, like where you install the Python. Like there is a machine, let's say you have got your laptop, right? Once you install the Python and you run that script on your laptop, then your laptop becomes a controller, right? So using Python script, then you just run that script only once, and then it will take the backup of all those 50 devices that you I mean, obviously it will be depending upon you, that how you enter your data, how you provide inputs to your Python. So it could be like 50 devices, 10 devices, 2 devices, whatever, right? But now Python will do that on your behalf. So earlier you were spending like hours, many hours, but now it can be done within 10 to 15 minutes. And these tasks can be performed by the Python in parallelly. Like it can start taking backup of all 50 devices in parallel. So it should not take more than 10 to 15 minutes. So that job can be done in couple of minutes instead of spending hours. And that's the beauty, or that's the power of controller based networking, right? And that's what SDN is, right? So then this controller based networking into the picture, right? So SDN is not something new, right? And Cisco was not really focusing on this SDN kind of thing. I'm telling you truth about the Cisco. Cisco was not really focusing on it. But then what happened? People like other vendors, such as VMware, right? VMware came up with NSX, right? Like they had a data center solution with automation. They came up with WAN solution as well. And they said, okay, you can also purchase the SD-WAN. Now in SD-WAN, again, like so many vendors came up quickly into the market. And one of them was viptela, right? So viptela SD-WAN, right? viptela was one of the vendor who launched SD-WAN technology. Later, what Cisco did in 2017, if I'm not wrong, in 2017, Cisco acquired this acquisition happened in 2017, if I'm not wrong, right? So Cisco acquired this viptela SD-WAN solution, right? They acquired this entire organization. So originally, the SD-WAN that we are going to learn is not from Cisco. Originally, it is from viptela. And that's why, you know, those names were like vBond, vSmart. That's the reason behind that, because viptela named them like that. vBond, like all the controllers and all the managed routers, like their name started with V. So that's why they call it vEdge, vSmart, vBond, vManage, right? So it was from viptela. So Cisco acquired viptela, and then it became Cisco SD-WAN. Right now, when we talk about, okay, so because Cisco was really behind than others, right, into this SDN kind of thing. So not only Cisco acquired viptela, but also one more thing that I would like to discuss here, that it doesn't mean that Cisco was not having the SD-WAN solution. They had that, like called IWAN, but that was a very, very poor solution that Cisco proposed to their customers, right? Like this solution was adopted by a couple of customers, not more than that, right? Like Cisco had very few customers who adopted this IWAN SD-WAN technology. Like it was kind of SD-WAN, but it was not adopted by the customers. But then Cisco acquired this viptela, and of course viptela was pretty much I mean, it was adopted by customers at wide level. The viptela SD-WAN, it was so simpler to configure, and then it had so many features, less bugs and all that. So yes, viptela really helped Cisco to push their SD-WAN product, right? So now, as of today in Cisco, if you talk about the SDN, software defined networking, we have got 3 solutions. We have got SD-WAN, that's what we are going to learn. Then we have got Cisco SDA, that this is called lane automation, or this is lane automation for Catalyst switches. And for data centers, they have got Cisco ACI. This is for Nexus switches. So they have touched everything. Like Cisco is now fully automated. They have automated everything, right? Or they have introduced the software defined networking for all three aspects. The LAN, local area network, that's the for LAN. They have introduced Cisco SDA. This is for like here you use DNS center, right? And this is for Catalyst switches. Then SD-WAN is for the WAN edge routers, for the WAN facing routers, and then ACI for the data centers. So these three solutions are there, right? When it comes to Cisco. Now, this SD-WAN is not only for, I mean, within SD-WAN, they have got like two options for you. Now, Cisco provides two different options to their customers when it comes to the SD-WAN. One is simply they call it Cisco SD-WAN. The other SD-WAN is they call it Meraki SD-WAN. So they have got Meraki SD-WAN as well. And that is also popular. Trust me. It is also very much popular. It is equally popular as Cisco SD-WAN is, right? So earlier Cisco had a problem that they were not having a solution or a product with the low prices. And for example, if there was a customer, the small customer, right? They don't want to spend that much money. So they were not like Cisco was not able to provide them the solution. But Cisco then acquired Meraki. I don't remember the year in which year they acquired this Meraki. So after acquiring this Meraki, now Cisco has got two different options. Like now they can target to all types of customers. Like a customer who don't want to spend that much money, they can also target that customer base by using this Meraki SD-WAN, right? So basically what Cisco says, right, it's not an official terminology, but you know, they say like the Meraki is for the poor customers and the Cisco SD-WAN is for rich customers, right? This is what sometimes they make a joke around that, right? So that's what they do. So if a customer is not able to spend that much money on IT stuff, then they will propose a Meraki solution for them. And it is very, very, very good solution for a small network, for a small customer. And then Cisco SD-WAN, yes, it is pretty much flexible. It gives you a lot of flexibility and of course with higher throughput and everything, right? So yes, Cisco SD-WAN is still there, right? So within SD-WAN, we have got these two solutions, Cisco SD-WAN and then Meraki SD-WAN. Cisco SD-WAN is like viptela SD-WAN, right? This is what we are going to learn through this training. We are not going to learn anything about the Meraki SD-WAN. We are going to learn about the Cisco SD-WAN only. So now you can see that SDN is introduced for each type of network. Like Cisco has provided SDN solution for everything, for WAN edge routers, for lane switching, and then of course for data center. All right. Now remember that when I talk about the SD-WAN, right? So as I said, earlier you had like DC1, still you are going to have like your primary DC, then secondary DC, then probably you would have MPLS, but now with SD-WAN, MPLS is not really necessary. So you would have like, if you still want MPLS, you can keep MPLS connectivity, but along with internet. So the branches would have MPLS, internet both, or just or just internet, or maybe, I mean, it depends upon the type of customer that you are working with. So branch 3 has got internet, MPLS both. Now the best thing with this SD-WAN is that these all routers, the WAN edge routers, like installed at branch level, all these WAN edge routers can be controlled by this SD-WAN. Only WAN edge routers, like for example, if you have got a router and then behind that you have got switch. So this lane switch cannot be managed by the SD-WAN. No, only WAN edge routers, the routers which are WAN facing, can be managed by the SD-WAN. So for lane switches, you have got SDA, software defined access, right? So these things are interconnected like SDA, SD-WAN, and of course for inside DC, you will be using ACI, right? So a complete solution is there when it comes to the SDN software defined networking in Cisco, right? So all the managed routers will be managed by the SD-WAN. So for example, if I go back and open up the diagram that I will be using for this training, this is the diagram, right? Using SD-WAN, you can manage only the managed routers, not these lane switches, or maybe towards lane you have got the other routers, right? Like this managed router can be managed through the SD-WAN, but not this backend router or firewall. So for that, you have got like the kind of SDA to manage those switches and non-SD-WAN routers. So if you want to manage your non-SD-WAN routers, and then you want to manage Catalyst switches, then use DNS Center for that, right? Using SDA is not mandatory, but at least for managing the devices for management purpose, you can use DNS Center. Now, DNS Center can be used for multi-purposes. As I said, you can use DNS Center to manage your non-SD-WAN devices, such as your normal routers or Catalyst switches. But also you can build SDA kind of fabric, right? But that's an optional, right? We are not going to cover that. I'm just explaining here, right? So using SD-WAN, you will be managing only managed routers like these routers, because these routers are directly connected with the transport, or the transport connections are terminating onto your managed routers. But the lane devices will not be managed by Cisco SD-WAN, right? Or by vManage, I would say, because ultimately this is the component which is going to act, or which is going to work as a management plane for you, right? So now this SD-WAN solution is this Cisco SD-WAN has provided us the solution for all of our problems that we had with the traditional networking. Remember that I gave you so many examples of the problems with the traditional networking. Like, for example, if you I gave you one example that, for example, if the MPLS provider 1 was the primary, 2 was secondary, now you want to flip that, right? Now you want to make MPLS provider 2 as a primary and 1 as a secondary. You can do it by just making some changes onto vManage. That's it. You just have to go on to vManage, make some changes, and done. Boom, right? Then let's say you wanted to modify the SNMP string. You go to vManage, modify that, push your change, done. Boom, within a couple of minutes. You wanted to change the NTP server IP, AAA server IP, DNS server IP, make the changes onto vManage, and it will be pushed. It will be pushed to all managed routers within a couple of minutes. Boom. I mean, that's how it has added, I would say, kind of a scalability as well as reliability, right, to your infrastructure. And not only it helps you to make the changes quickly, but also it helps you to perform the troubleshooting quickly. Because if anything happens into the network, then vManage can also generate the alerts against that. And for all those alerts, you can set up your vManage to generate an email to your team, right? You can create a distribution list for your entire team, a kind of DL, right? And then you can put on to your vManage. And then if there is an alert generated by vManage can send an email to that DL. So obviously, someone must be working in that shift. As soon as they get the email, they can start working on that. In fact, if you talk about the SDA, software defined access, in that we use a controller called a DNS Center. DNS Center can also tell you that, okay, what is the problem? Where is the problem? Like if you are taking the help of DNS Center doing troubleshooting, DNS Center itself is capable to tell you that where exactly problem is. And it will help you. It will ask you that, okay, first check interface status, then check this, then check that. It will give you the troubleshooting steps as well. In fact, you can ask DNS Center to take those steps as well on your behalf. So that kind of automation has been evolved, right? But obviously, we are going to learn about the SD-WAN only. So yes, we will be stick to the SD-WAN only. But yes, in Cisco SD-WAN, when it comes to SDA, we have got 3 solutions: the SD-WAN, ACI, and of course the SDA, the software defined access. As I-MEDITA, we are covering only two of them as of today, the SD-WAN and SDA. We do not cover the ACI as of today, but yes, we have a couple of plans, or we have got plans around developing the content for ACI as well. But for now, we are just focusing only on SD-WAN and SDA. Okay, all right. So yeah, I mean, that's that. I think this is enough for today. I just wanted to give you a kind of introduction, right, of the SD-WAN. I believe that everyone understood the requirement or the problems that we had with the traditional networking, and why the SDN or software-defined networking was needed. I have many other examples as well, like reasons behind evolving the SD-WAN or SDN, software-defined networking, right? The DevOps, right? Initially, DevOps was meant for the system engineering only, right? Like for servers and all that kind of stuff, right? For application deployment. But then it was like you have got a like all together this network infrastructure, and then your server infrastructure, and then application infrastructure, right? These all component works together, right? It's like a single train, right? Having different coaches, right? Now, let's say for application development and for deploying applications onto servers, you got DevOps, which could help you to develop applications and to deploy them quickly, right? In maybe a couple of hours, right? But then making changes accordingly in infrastructure, network infrastructure, was still a challenge. It is like you have got a train, some coaches, like some of its coaches, the train coaches are supporting a speed up to like maybe 150 or maybe 200 kilometers per hour, right? But some coaches are still supporting like kind of 100 or 80 kilometers per hour. So again, there was no advantage of having those coaches supporting like speed up to 200 kilometers per hour, since you have some coaches supporting a speed of 100 kilometers per hour only, right? So there is no advantage of doing that, right? So like we had issues with the network infrastructure. So then DevOps was introduced into network infrastructure as well, and that's why you have got like this Python scripting is there, Ansible is there, REST API is there. So you create those small applications to make the changes into your network quickly within a minute, right? So the DevOps is now has become NetOps and as well as SecOps, right? So you must have heard about it as well. So I can give you like many examples like that, but for now let's focus only on SD-WAN. I have given you a complete list of the topics that we are going to cover during this training. So that's one thing. Second, I've explained you why SD-WAN was necessary. Third, I have explained you like earlier it was viptela, now it is Cisco SD-WAN. Fourth, I have also told you that now Cisco has renamed it with some other names like the Catalyst name. Now they don't call it Cisco SD-WAN. They call it, okay, let me just quickly open up the Cisco's website here. Products, networking, wide area networking. So Cisco DNA software for SD-WAN routing. And then we have got like, okay, they have not even updated their website fully so far. So they are still calling it like vManage and so, right? So, but they have renamed it, right? Maybe that's going to take place. I just wanted to show you those names, but that's okay. I will show you tomorrow or maybe some other time. I'll explain you those new terminologies as well that Cisco has introduced for their Cisco SD-WAN, right? So their website is still not updated. Look at this. They're still displaying it as a vManage, right? Okay, all right. So that's it for today, and we'll continue tomorrow. And tomorrow I'm gonna start with the architecture of the Cisco SD-WAN. So I'll be talking about the different components involved in Cisco SD-WAN, such as vManage, vSmart, and vBond, and their roles. So today I just given you kind of an overview of the SD-WAN, right? And tomorrow we basically gonna start with the actual training. Any question from anyone? No? Okay.
Sir,
Mm-hmm.
Cisco Meraki devices using for India also using, sir.
Yeah, we are using
That is the Cisco Meraki device is wireless device, is correct?
not only wireless device. As I said, they have a lot of things, right? So they have got wireless devices, they have got cameras for you, they have got switches, they have got firewalls, right? And they have got the SD-WAN functionality as well within that Meraki solution.
That is only one dashboard is there.
Yeah, there
In
is just
all,
one orchestrator. Yes, there is just
yes.
one dashboard for all these devices, whether those are
Um,
cameras or those are APs or those are switches or those are firewalls. So there is
the
just one
dashboard,
dashboard for everything.
everything is providing. Is
Yes.
correct. Yeah. Okay, sir. Thank you, sir. Thanks for.
All right, then that's it for today and see you tomorrow and have a good rest of the day. Bye for now. So in previous class, like yesterday, we had a discussion around the number of topics that we are going to cover, the number of labs, the lab environment, like the design of the lab. This is something that we have already discussed. Now we are going to talk about Cisco SD-WAN solution overview. So, and then thereafter I will immediately start with the architecture of the Cisco SD-WAN. If you look at the right, this is something that I discussed yesterday. So it's just a kind of recap for you, for all of you. So earlier we used to have this kind of connectivity, like we used to have the data centers where we are still having data centers, but the connectivity has got changed, right? So data center is connected to the internet, and then through the MPLS, your branch office is connected. So if a user sitting inside a branch office wanted to have the access of the on-prem application, obviously through this WAN connection, through this MPLS connection, user will come to this data center and will have access to those applications, right, which are hosted inside data center. Apart from that, if any end user wanted to have the access through the internet, I mean, to the internet itself, again, all the users will be backhauled into data center through the MPLS link, and then they will go to internet and then will come back in same fashion. This is what I explained to you yesterday with the larger diagram, right? So it's the same thing, right? But now things have got changed. Why? Because there is a concept of the multi-cloud, right? The concept of the multi-cloud has evolved. Like nowadays people are moving more and more applications onto like public clouds such as Azure, Microsoft Azure, and then AWS or maybe GCP, like that, right? So applications are moving in multi-cloud environment. Then a lot of applications are offered by the vendors as a SaaS, right? Software as service, such as Office 365 is there, then Dropbox is there, Salesforce is there, right? So there are many applications which are offered by the vendors as a SaaS, right? Software as service. The internet, right? The internet, earlier we used to have the access of the internet through the data center, but now users would require that direct internet. Why? Because the SaaS based applications can be accessed through the internet only. So if you are not providing direct internet access to your users, then they can't have access to those applications directly. I mean, technically it will not be possible for them to go and access those applications directly, right? So I mean, now since the requirement has got changed, right? The requirement has got changed. Therefore, it is not enough to have just MPLS connection at the branch level, right? It is also important to have the internet connection at branch level, so that if users, like by making some changes onto this branch router, we can enable kind of direct internet connectivity, at least for the SaaS based applications. So if a user is trying to access Office 365, then for those users we can build a policy over this branch router that, hey, you should go to internet directly if accessing those SaaS based applications like Office 365 or Dropbox or whatever, right? So for all of those SaaS based applications, you should go directly over the internet, right? So that's what we can set up on this branch router in SD-WAN, because in SD-WAN, the routers have application visibility. they can perform application aware routing, so we can build the policies accordingly, right? So that's what we can do. So the requirement has completely got changed, right? So therefore the internet is moving to the edge now, right? Earlier it was not. So now even the app content is become, it has become rich, dynamic, and web based, right? In most cases, the app delivery is through the cloud, then SaaS, and then virtualized within our own data centers, right? So data center is still in use, the cloud is in use, and then of course the SaaS, right? Software as service is also in use. Then the end users are accessing the applications through their mobile phones, through different types of devices, right? So basically, applications are moving to the cloud, internet as is moving to the remote side, business mobile device, BYOD, guest access. So that kind of things are happening, and you require higher bandwidth, right? You require higher bandwidth to access those apps, right? So bandwidth requirement has also it has also got significantly increased, right? Let's not talk about this for now. So let's talk about the SD-WAN solution. So we had so many problems earlier, and the solution is the Cisco SD-WAN for all of those problems that we have discussed yesterday, right? So and of course today, right? So the only solution that I see is the Cisco SD-WAN solution, right? Also, I discussed yesterday that within Cisco there are multiple SDN solutions such as Cisco SD-WAN and Cisco SDA, as well as there is a Cisco ACI. So for different environments, Cisco has built or Cisco has offered different SDN solutions. So if you are looking for like to manage your managed routers, right? Only managed routers, then go for SD-WAN. And then if you are looking to manage your LAN devices, then go for the lane automation that can be done through the SDA. And then for data centers, especially where you have got the Nexus switches, then you will have to go for the ACI controller, right? So like we have got different SDN solutions within Cisco for different environments. So if we talk about this Cisco SD-WAN solution, so obviously it has got like the transport independent WAN fabric. Like it is a transport independent technology, first of all, right? So it is a very important statement here, right, in the beginning of Cisco SD-WAN technology. So SD-WAN can be utilized with any type of transport, whatever you are using. So maybe let's say if you are using just MPLS, you can keep using MPLS. You want to include internet along with MPLS, you can do that. Or maybe you want to use 4G LTE type of connectivity, you can also use that. So basically, this technology is a transport independent technology. So as underlay network, you can use anything. Like in underlay, you can use MPLS, you can use normal broadband connection, you can use internet leased lines, you can use 4G LTE type of network as to provide underlay connectivity between remote sites. Okay, so what I'm saying here is that let's say you have got branch 1, right, and then you have got branch 2. Now you can try to interconnect them using MPLS, and SD-WAN does not restrict you from being from using this MPLS transport connectivity. Maybe you can use internet leased line, right? So it's up to you. You can also use the broadband connection, business broadband connections. You can also use 4G LTE, so to interconnect those branch offices. So that's okay, and that's why I am making this statement that this Cisco SD-WAN is a transport independent technology, right? So it can still build, like it can build the overlay fabric without depending upon a specific type of underlay technology or underlay transport, right? So that's that. So that's a good news for us. In fact, during migration, it is going to help us a lot, right? Because we are not depending on a specific transport. So whatever transport you had in the existing site, you can keep using same. All right, then it gives you endpoint flexibility. So what's the meaning of endpoint flexibility here? Here in this, in this diagram. So the meaning of the endpoint flexibility is that, like you can have a hardware managed router. That's okay. Like if you are purchasing a managed router from Cisco, you can purchase that, right? The hardware device can be purchased without any issues, right? That's one thing. But apart from hardware devices, you can also use the virtual managed routers. And the virtual managed routers can be installed on top of x86 platforms, right? Like you can take some examples of hypervisors, like you can install the virtual managed routers on top of ESXi, maybe KVM, right? And even within Cisco, there are some platforms. I'm not sure if you have heard about them, but there are some platforms called ENCS boxes, right? So you can leverage those ENCS boxes, right? And over a single ENCS box, you can deploy a firewall. This is virtual firewall along with this virtual router, the virtual managed router. So that kind of flexibility it gives you, or it gives us, right? So endpoint flexibility, that's the meaning of that endpoint flexibility, that you have got the hardware device, like hardware routers, fine. But also you can install them on top of the hypervisor such as ESXi, KVM, or and like that. So that's the endpoint flexibility. Then cloud delivered. So basically you can deploy all your control components inside cloud. You can use Amazon Web Services, AWS, you can use Microsoft Azure for that purpose, right? But all of the control components. So mainly, like when I talk about the Cisco SD-WAN, you have got like these three control components. Mainly vManage, vSmart, and vMount, right? These are the main three components participates in Cisco SD-WAN technology, right? vManage, vSmart, and the vMount. Right? These are known as control components in Cisco SD-WAN. So these control components can be hosted either in Amazon Web Services or in Microsoft Azure Cloud, right? So you can deploy them based on the availability of the public cloud, right? But yes, these all control components can be hosted inside cloud. Now, to automate that process, you can also use the NSO. So NSO is a tool which is you know which is used by Cisco, right? Cisco uses this NSO tool to automate the deployment of the control components inside the cloud itself, right? So again, NSO is kind of an orchestrator kind of thing, right? Which can be utilized to deploy your control components inside the cloud, right? So that's something that you should remember, right? So you can use these tools to deploy your control components. But as a customer, right, I would not have access to these tools as a customer. Ideally, these tools are meant for the managed service providers. Like you are having a lot of customers, every day you are signing a deal, right? And every day you are deploying the controllers for many customers. So if you're doing it manually, then obviously it is going to take long time, right? So to service on time, to provide services to our customer on time, it is better to use some automation tool to deploy the control components, right? But as a customer, let's say I'm just deploying control components for myself, then obviously I would not have access to these tools, these automation tools, right? The SD-WAN gateway can be a, like SD-WAN gateway, you can define a gateway site here, like you can define a co-location, right? So that can also be done. It also supports the integration with SaaS-based cloud applications. Like you would have a topic like basically under data plane policies, you would see that I will be deploying cloud on-ramp services for SaaS application where we can even implement the DIA. So for example, if there is a branch user, let's say branch user is sitting behind this VANES router. So if I wanted them to have the access of the Office 365 directly through the internet connection, they can have that, right? Or maybe ServiceNow or maybe Salesforce. So they can have that, right? So that's SaaS cloud apps, right? Or I can call it cloud cloud on ramp for software as service, or I can call it cloud express for SaaS, right? Apart from that, you must also remember that sometimes you may have to configure cloud on ramp for infrastructure as service. So when I say infrastructure as service, which means that within cloud, within Amazon cloud, or maybe Microsoft Azure cloud, you have got a kind of smaller DC, right? Smaller DCs hosted inside the cloud itself. And now what you want is that you want to deploy the managed routers, the virtual managed routers inside cloud itself, so that the on-prem managed router can directly establish the overlay tunnels with the routers hosted inside the cloud. And that way, the on-prem user can directly have access to the applications hosted in cloud, right? So this is called cloud on ramp for infrastructure as service. So this is something that I will be performing. Like I'm not saying that I will be doing lab, but instead doing off lab, I'll be just showing you all the steps that you need to take if you are doing the deployment of cloud on ramp for infrastructure as service, right? So that's what I will be performing right in front of you, right? And these are the features supported by the Cisco SD-WAN solution, right? I mean, this is how the Cisco SD-WAN solution is being designed, right? So now I will move on to the next slide. So now basically there are so many things that you got within Cisco SD-WAN, like analytics, monitoring, and then operations and all that, right? So obviously all these features are supported here, right? So and if it comes to the when it comes to the service delivery platform, right? So then you can see that it supports routing, it supports security features as already described, right? Yesterday I described that which all security features are supported by the managed routers, right? And then it also does the segmentation by the help of VRF. You can also apply the quality of service. It also supports multicast routing. You can also insert the services in case if you want, and the survivability, right, of the connectivity, right? And then again, the transport independent fabric, right? Also, you can create, like you can configure traffic engineering based on your requirement, like you can direct some specific type of traffic to a specific transport, right? So that's an example of the traffic engineering. You can define the application SLAs, like you can also create the IP SLAs, right? So, I mean, basically, we do not call it just IP SLA. Basically, we call them application SLAs. So we can define SLAs that, okay, if the connection is, is having less than 1% of the drops, and then latency less than 40 milliseconds, and then jitter less than 30 milliseconds, I'll keep using this circuit as a primary circuit. But then if if that condition fails, if SLA is not met, then I will move on to the next available interface, right? So I mean, that way you can define your application SLAs, right? Then you have an option to define the topology for each segment. So when I say each segment, which means for each VRF. So for example, if you have got like two VRF that you are using, one for your corporate users, right? So all the corporate users will be connecting to the corporate VRF, right? And for that VRF between remote sites, you want full mesh type of connectivity. So yes, you can keep it full mesh for that VRF. But apart from that, let's say you have got another VRF, and let's say your organization was, let's assume that your organization was a financial based organization, and therefore you have to comply with the PCI compliance, right? So as per the PCI compliance, then all of your like ATMs or all the machines wherever you are doing the financial transactions must be part of the separate network, right? So you decided to create another VRF for that purpose, right? So let's say you created one more VRF called FinCorp, right? You created one more VRF and you have put all those devices wherever you are making those financial transactions, right? Part of that FinCorp VRF. So you decided to create like two different segments, one for your corporate users and second for your POS machines, and then, wherever you are making those financial transactions. So you decided to create one another VRF for that purpose, which you can call as a FinCorp, right? I mean, you can name it anything, but I just took an example. So then what you can do is that for corporate VRF, you can keep using you can use the you can use full mesh connectivity, but then as per the PCI compliance, you should not be having full mesh connectivity. Like, you should not be having branch to branch connectivity, but I mean, rather than that, you should have connectivity from branches to your data center only, at least for that VRF. So yes, for FinCorp type of VRF, you can use hub and spoke, or you will be using hub and spoke topology. So now you have got two VRF in your environment, right? And then you have got like two different topology, and that's the meaning of per segment topology, because for each segment you can have a different topology. You can keep it hub and spoke, you can keep it kind of partial mesh, right? Or you can keep it full mesh. Then secure perimeter, right? So when I say secure perimeter, because yesterday I discussed about it, that all the security features can be deployed. Like you can have a firewall deployed, you can have IDS, IPS, URL filtering, and all that. So I mean, that's that. So these all features are provided in Cisco SD-WAN, right? And then it is a software defined, yes, right? It is a software defined networking. It supports like, obviously, you can deploy your control components inside cloud. Application awareness is there, scale and flexibility. It provides security, right? You can increment authentication, you can enable encryption, you can do segmentation, you can define access control, you can perform service chaining, right? And also it is open for automation, orchestration, best of breed integration. So you can perform the integration as well, right? I will be talking about that integration as well. So flexible connectivity, as I said, that you can interconnect your branches, right? Using MPLS, you can interconnect them using 4G LTE, or maybe you can interconnect them using internet connection. And when I say internet connection, which means I'm including both the internet leased lines as well as the normal broadband connection. Make sense? So after all, it will help us to lower the WAN cost. Because if you are relying just on MPLS, right? If you're using just MPLS, like multiple MPLS connection from multiple providers, then obviously cost will get increased, right? Significantly. So I mean, obviously operational cost has been reduced by the help of SD-WAN, because it is not mandatory for you to use MPLS anymore. And why it is so, that I will explain later, that why MPLS is not really needed. I said that you can also perform the service ingestion, and that way you can preserve the bandwidth, right? So ideally what happens is that you get the data center, right? So in your right side in this slide, you can see that there is a data center, right? At your right side. At your right side, you have got the data center. That's where you have got this firewall, right? So if users from site A are directly coming to DC, right? Let's say user is going to this firewall just to see if this user is allowed to have access to this web application or web app server or not, right? Now, let's assume that even this user was not allowed. Let's say this user was not allowed to have access to that app server. So this user will go to this firewall. Firewall block will block this access, right? I mean, obviously that's what firewall is doing there, right? So if someone is not allowed to have access to the application server, firewall will block that, right? All right. But the problem is that though this user was not allowed to have the access of this app server, still user is hitting to this data center firewall. While hitting this data center firewall, it is also consuming your WAN bandwidth of data center, because the user is getting entry into the data center, right? Although this user is not allowed through the firewall, but it is hitting that firewall, and that way consuming this data center WAN bandwidth unnecessarily. Now, Cisco has proposed one solution here called service chaining or service ingestion. What we can do, we can go to another regional kind of data center, regional site, right? And within that regional site, we can install one more firewall. And then we can advertise that as a service to this site A. So what we can do then, that we can build all the policies on this firewall hosted at regional data center or at regional site. Then all traffic from the users from site A will first come to this regional hub like this, will go to this firewall. If this firewall allows, then only this traffic will be forwarded back to DC. So now DC is gonna receive only trusted traffic, and that way you have reduced the burden of this firewall hosted in DC, and also you have reduced the uses of WAN bandwidth in data center. Because if user was not allowed, then this firewall hosted within this region, right? I mean, inside regional data center, or you can call it the regional headquarters. That's where the end users will get blocked by this firewall. So that way you can prevent your DC firewall from overutilizing, as well as you are saving the WAN bandwidth of the data center. So that way you can do that, right? So that's service ingestion and bandwidth preservation. So that feature is also supported in Cisco SD-WAN. Application-centric networking. This is what I stated even yesterday, and I recommended that we must be using this solution just because of that it has got the application visibility as well, right? Because you can perform routing based on the applications now. You can build your policies based on the applications. Why? Because your routers in Cisco SD-WAN have got application visibility. So as I mentioned yesterday, that you can create policies saying that, hey, for ServiceNow, Salesforce, I want to send traffic directly over to internet. You can do that. You can say that for VoIP, voice over IP, let's say you are using SIP, right? SIP. And then for video calls, then you are using RTP type of protocols. Then you can create another policy that for RTP and voice over IP, which is SIP, right? For SIP and RTP, the traffic should be forwarded over the MPLS connection. Yes, you can do that. And along with that, you can also define the SLAs while defining the preferred transport for a specific applications, right? So the routers would have a application visibility. Therefore, we can define the application aware routing actually onto your managed router. So that's that. Secure segmentation, right? So as I told you, that segmentation will be achieved by the help of creating VRFs, right? So for example, this is type of a network that you are using here, right? So in corporate data center, let's say you have got like two VRFs. One is Corp VRF, and then another one is FinCorp, right? And this FinCorp is created everywhere. Like even in cloud data center, you have got Corp as well as FinCorp. In branch offices, you have got Corp VRF, you have got FinCorp. Inside campus, you have got Corp VRF, you have got FinCorp. In a small office, you have got Corp VRF and also FinCorp. Now, what happens is that in Cisco SD-WAN, the IPsec tunnels will get established between the managed routers, between remote sites automatically. So in Cisco SD-WAN, all these managed routers, right? Like for example, this is your cloud data center, right? That's where you have deployed the virtual managed routers. So from this small office, home office, this managed router will establish a tunnel, IPsec tunnel with cloud managed routers, with corporate data center routers, with campus router, with branch router as well. So that's the default behavior of the Cisco SD-WAN, like building up the full mesh connectivity. And to build full mesh connectivity, right, in overlay, it will be using IPsec tunnels by default. So the IPsec tunnels will get established between the remote sites over any transport. Even if you are using MPLS, still the IPsec tunnel will get established on top of MPLS. So MPLS is an underlay technology, but in overlay, managed routers will be establishing or will be creating the IPsec tunnels between the remote sites, right? So since you are creating a secure tunnel between remote sites for sending user traffic, for transferring user traffic, and also while sending traffic through the IPsec tunnel, right? Traffic for each VRF will get segregated. It's not like traffic will get mixed match. No, it is not going to be. So the users part of corporate VRF across all sites can talk to each other. But the users from corporate VRF cannot talk to those users participating in FinCorp VRF, which means by default, like let me tell you, this VPN 1 is nothing but it is a VRF 1. So remember that in Cisco SD-WAN, by default, only intra VPN traffic is allowed, or intra VRF, right? Only intra VRF between the remote sites. You have got the IPsec tunnels there, and IPsec tunnel will be treated as a trunking port between the switches. Do you remember that when we talk about two switches, Ethernet switches, right? So between switches, we always build the trunking. Why? Because because to allow multiple VLANs traffic over to a single link, right? That's the purpose of trunking between the switches. So this IPsec tunnel between remote sites, for example, corporate data center and this branch office, there will be an IPsec tunnel over each available transport. So whether you have got MPLS or internet, over each available transport, it will establish an IPsec tunnel. Now, through those tunnels, your user traffic will flow. In that way, like it will make sure that if there is a corporate user traffic going from branch to DC, right, then it should not be forwarded to the FinCorp VRF. It will make sure that. So it supports end-to-end segmentation. So it's not like obviously traditionally we had VRF concept, like traditionally we had the concept of the VRF onto Cisco routers. But those VRFs, like VRF Lite especially, VRF Lite had local significance, right? I'm not talking about the MPLS VPN, right? I'm talking about the VRF Lite, right? So VRF Lite had a local significance, but in Cisco SD-WAN, even this VRF Lite, obviously we are using VRF without MPLS, right? So I will still call it VRF Lite. But in in SD-WAN, in software defined wide area networking, the VRF, right? VRF Lite will provide you end-to-end segmentation, right? So even if users are sitting at different sites, still they can talk within the VRF, right? So that's what the meaning of end-to-end segmentation. You can also have local internet breakout, which is also known as DIA, direct internet access. You can do that if you have got the internet connectivity. If there is just MPLS, then obviously you can't do that. But if you have like one MPLS connection, one internet, then you can also have the local internet breakout by the help of DIA. You can also have the cloud gateway. You can go to cloud, right? And then obviously you can access your cloud applications through that cloud gateway as well. So it depends, right? Like how you want to establish your connectivity. It is also possible for you to integrate it with Cisco umbrella, like Cisco SD-WAN can be integrated with Cisco umbrella very easily. It's so easy to integrate it with Cisco umbrella, but that's not something that I'm going to discuss now, right? So let's skip it for later. Now I see that Kanchi, you are raising your hand, right? So yesterday I made this statement, nobody has to raise any hand. Nobody has to sit quiet. No. I mean, it's not mandatory. You guys are always free to unmute yourself. Okay. At any point of time, you can unmute. Even you can stop me while explaining in the middle of the topic as well. You can stop me. You can ask your questions. Right. So if you have got any question, please go ahead, unmute yourself and immediately ask those questions. Sometimes I might say that, okay, I'm going to cover it in future, maybe next 10 minutes or 20 minutes or maybe an hour. So I'll cover it later. But if I have already, let's say, if it, I mean, if I think that, okay, that topic was already covered and you have got a doubt, then I will explain it immediately. I will stop. I will pause my topic for a moment and I will explain it to you. I mean, I will clarify things to you, whatever questions you had. So it is for all that if you want to sit unmuted, you can sit unmuted, but the point is, the condition is that there must not be any background noise. If there is a background noise, I will put you guys on mute. However, you can still ask those questions, even if you have the background noise. So along with background noise, you can still ask your questions, but you can't sit unmuted, right? You can sit unmuted only and only if there is no background noise, right? So make sure, I mean, you do not need my permission. You don't have to raise your hand before asking questions. No. So Kanchi, can you please unmute yourself and raise your concern?
Now it's okay, sir. Understand the
Okay.
doubt clear, sir. Now it's okay.
All right. Okay. Give me a moment. Napoleon, I would highly recommend you to unmute yourself and ask the questions, not to put the questions in chat. Because my focus would not be on chat. In most cases, I will not be reading the chat. Better that you unmute yourself and speak up. So that would be that would be an ideal situation for me because sometimes I even do not look at the chat. So now the question is, the question that Napoleon is asking me is, which scenario we need to use the physical controller, KVM, cloud host controller for vBond. Okay, that is something that I have not started so far. So I'm going to cover that topic in future, right? So for now, I was just talking about the different features that we have in Cisco SD-WAN, right? But going further, I'm going to have a discussion around these control components. All right. Cloud ready WAN, obviously, as I said, that you can deploy, you can configure Cloud Express for SaaS, Cloud Express for infrastructure as service. So these are very, very good features that we have got in Cisco SD-WAN, and you would say, wow, once we cover them. Now, SD-WAN management, right? So obviously, the vManage, you would be utilizing that vManage, right, for the management purposes. So vManage can be hosted inside a cloud, as well as you can host your vManage on-prem, like on your on-prem servers, right? So that is also possible. So it depends that how and where you want to deploy your vManage. And then analytics, right? vAnalytics. vAnalytics is something different, right? So I will be talking about that a little later. So let's go ahead and then let's move on to okay. I mean, they are also talking about the integration. I'm not going to cover this integration for now, that which all integrations are supported. Let's quickly start with the architecture now, because within architecture, I will speak about this integration part as well, or the integration plan, how and what we can integrate with your Cisco SD-WAN. So I will talk about that later. But yeah, from managed WAN to SD-WAN network as a service. So you can also have network as a service in Cisco SD-WAN. But yeah, I mean, let's not talk about the network as a service. Let's not talk about that functionality of the Cisco SD-WAN, where you can utilize it, or you could utilize it network as a service for different customers. Okay. All right.